So this one I'm going to treat a little bit differently, not for any reason, just so that you can see it can be done differently. I'm going to treat this one by dealing with the inside first and distributing the exponent last, just so that you can see it really doesn't matter. So in terms of the inside, the first thing I notice is that the ends have negative exponents, so they're going to move. So now what you have is you have negative 9m n to the 5th over 3m n to the 3rd, all raised to the 2nd. The negative 9 is not going to move because it's a negative 9, not a negative exponent. That's what makes the difference. So I'm going to say negative 9 divided by negative 3 is negative 3 over 1. The m's, they cancel right on out. And then for the n's, you subtract those exponents and you get n squared in the numerator, because that's where your larger n was. And that whole thing is still being raised to the 2nd power. Now, since that is a 1 just in the denominator and there's nothing else there, and it's the denominator, I don't need that. So I can look at this as just this. Take that one right away. If it was in the numerator, I could not take it away. Now I can just distribute the power. So I have negative 3 to the 2nd and n to the 2nd to the 2nd. Negative 3 to the 2nd means negative 3 times negative 3, that is positive 9. And the inner outer exponents multiply to make n to the 4th. And that is number 7. Look what Mr. Colburn brought me. So thoughtful. Let's move on. Number 9. Okay, so the first thing with this question, I see that there are no outer exponents. And then this is the thing that people find confusing, is that that is a fraction and that is not. But I can make that a fraction. All I have to do is put it over 1. So that's what I'm going to do. I'm going to put it over 1. And we know from way back when in middle school that when you are multiplying fractions, you multiply straight across the numerators and straight across the denominators. So when I multiply straight across the numerator, I don't see a number here, so that means it is a 1. I would do negative 8 times 1, which means negative 8. To multiply r to the 3rd with r to the 7th, you would add the powers, so you're going to get r to the 10th. To multiply s to the negative 5th and s to the negative 5th, you would add the powers. That would give you s to the negative 10th, because negative 5 plus negative 5 is negative 10. In the denominator, 1 times anything is going to keep it the same. So your denominator is just 2r to the negative 4th, s to the 7th. From here, I would probably reduce negative 8 and 2 to be negative 4 over 1. And then my s to the negative 10th has to move down to the denominator. And my r to the negative 4th has to move up to the numerator. So in the numerator, I will have r to the 10th and r to the 4th. In my denominator, I will have s to the 7th and s to the 10th.
Is that automatic one-shot kill? Is that automatic one-shot kill?
Shh. Now I take a look and I see I have 2 r's multiplying, so I'll add those powers, and I will get negative 4, r to the 10 plus 4, which makes r to the 14th, over 1, and then to multiply those s's, I'll add those powers. S to the 7 plus 10 is s to the 17th. That is your final answer. The only thing you could change if you'd like is you could take that 1 right out. And there is number 9. Handy dandy eraser. And here is number, oh no, 11. Okay, there is a whole lot going on here. What I would probably do first is reduce. The only reason I would make that the first thing is because I see that this is an 8 and that is a power of 3. And if I don't reduce it first, my numbers are going to become so large I'm not going to want to reduce them at the end, but I'm still going to have to. So I'm going to do this from the inside first. So negative 4 over negative 8 is positive 1 over 2. This b to the negative 2nd needs to move down, and the c to the negative 7th needs to move up. So now what you're going to have in the numerator, you'll have the c to the 7th, the c to the 3rd. In the denominator, you'll have the b to the 2nd, that moved down, and the b to the 4th, that was still there. And that's still to the negative 3rd power. Now you'll look and you'll say, oh, I'm multiplying these two c's. That means I have to add the exponents. So in the numerator, I'm going to have 1c to the 10th over. In the denominator, I'll have the 2. And I'm multiplying the b's, which means add those exponents. So that is b to the 6th, all raised to the negative 3rd. From here, I would distribute the power of negative 3. So that means this is going to be 1 to the negative 3rd, c to the 10th to the negative 3rd, over 2 to the negative 3rd, and b to the 6th to the negative 3rd. I'll multiply these guys because they're inner outer exponents. So I now have 1 to the negative 3rd, c to the negative 30th, over 2 to the negative 3rd, b to the negative 18th. And I know I keep telling you guys you can't leave negative powers in your final answer, so every single one of those has to move. So now your numerator is 2 to the 3rd, b to the 18th, over 1 to the 3rd, c to the 30th. Max, 2 to the 3rd means 2 times 2 times 2, which makes 8. So in the numerator you have 8b to the 18th over 1 to the 3rd is 1 times 1 times 1, still 1, and that's 1 c to the 30th. That 1 is optional. And that is your final answer for number 11. And I'll be back with 13 and 15.